Hello, physics, medical physics, Raman spectroscopy. Raman spectroscopy is a diagnostic technique. It can be useful in plastics, in material science, in nanomaterial, in mineral, and in biomedicine, in identification and characterization of many things. So, in the plastic identification of the most common plastic waste, so is in environmental cleaning. So recycling, rapid plastic identification is necessary for recycling the waste materials. Material science, the material structure to identify the material structure, so it is very useful for material science, and also identification of in medicine pathogen. In nanomaterial, in 2D structure, in 1D structures, in 2D structures, graphene. So to predict the thickness of the layers of the graphene, so that can be done by the Raman spectroscopy, and also 1D in carbon nanotube, CNT. So distinguish from the continuous monolayer from the defective region, so that will be useful. In archaeology, it is very useful uh, to know the origin and the continuity of the minerals. In biomedicine, is the identification of biomolecules and early detection of disease in vitro and in vivo, both conditions. So and solve many medical problems. So this is very useful. And also in biomedicine, it's cancer detection, and also in the tears in this, they should the Raman, with the Raman we can make the classification of tyrosine and carotenoid and phenylalanine. The patient with the cerebral ischemia and cerebral infraction, so we can find this identification of these patients based on the tear analysis using Raman spectroscopy. So Raman spectroscopy is the analytical technique. It is sensitive, it is accurate, it is fast, it is non-invasive, non-destructive. And so Raman spectroscopy is in fact the interaction of light with the matter, and usually is a solid or sometimes liquid. So light interaction is with the chemical bonds, or light interaction. So it is with the chemical, usually with the chemical bonds, and there are two things one will discuss further. So light interaction with the matter is in a two way. One is elastic, another one is inelastic. Inelastic energy is conserved, and energy is not conserved. So when energy is conserved, so the wavelength coming in is the same wavelength is going out in all directions. It's just scattering. So this is called a Rayleigh scattering. Is not useful because it doesn't bring any information about the solid. Is the material. So this is matter. But on inelastic scattering, lambda comes in, lambda not go out on on different directions. But it's the amount is very small. 1 photon per million. 1 photon per million is very uh, weak signal, but it is very useful. It's have a different wavelength. So usually lambda naught is larger than lambda 1. So that means energy, more energy comes in, less energy is here. So if it is a 5 joule, so say it is 4 joule. So 1 joule is in heating or sound is used. So first one, where is the elastic, is a Rayleigh scattering. Where is the inelastic, it is a Raman scattering. So if you look at the intensity, if this is the light comes in and this is material, so this is matter. So intensity I naught, and this is inside is I z. Z is the distance. So this one is z. So I z is equal is given by Beer-Lambert law. So this intensity is goes decreasing. So this is z, and this is intensity. So I naught mu is attenuation coefficient. So how much intensity is laser light is absorbed by the material, and z is the length. So this one, so I brief this one. So Raman scattering, so it's a light matter interaction, elastic scattering, Rayleigh, inelastic scattering, Raman. In a Raman scattering, there are two things. One is a chemical interaction with the chemical bonds. It's actually with the electron density. And with the electron density, this excitation of electrons in vibration modes, and frequency is shift. So from large frequency to low frequency, or in term of wavelength, lambda comes in, lambda naught goes out. Lambda naught is larger. Lambda not larger, or frequency is smaller. So this is the difference. This is shift. So blue is high energy. So this is high energy. Red is low energy. So that is the difference. So that is with the chemical bonds. And when it's a scattering also happen with the characteristic lattice vibration. Lattice vibration is the whole uh, arrangement of the molecule. So this whole lattice vibrates. So the framework versus bonds. So there is also the same frequency shift is observed. So this frequency shift, whether from the bonds or whether from the framework, it is the fingerprint of the material, and it is very useful. So Raman spectroscopy. Frequency shift is a fingerprint of the material, and the Raman photons are collected. They enable us the identification and characterization of the material. So Raman technique, the Ram data have a many wavelengths at the different positions. So it's a large data set. It is a complex. It is it contains a random noise and background noise, and we need a clean data, because raw data, to clean data we have to do some kind of a experimental adjustment. So new filters, new wavelengths, and some other techniques, and also some computational inputs and skill we have to add this one, and some qualitative analysis evaluations, some software, some other uh, programs to in order to get a clean data, and it is time consuming. Another one is raw material. To clean data we need a new analytical technique, and this can be artificial intelligence, machine learning, that enables us to make a computer to learn. So make computer learn without explicit programming, and uh, it make a prediction, it makes decision, and need algorithm. So basically that is the algorithm which is required. So Raman spectroscopy, machine learning, and is algorithm, so list of instructions of a task. So these instruction iterates continuously and on a given data sheet and finds a function to solve the task. So algorithm, so instructions find a function f and then it solve the task. So raw data to clean data. So we introduce machine learning. So machine learning speeds up the experimental analysis. It is accurate, it is fast, and it utilizes less computational skills, resources. So machine learning, new data establishes connections, patterns, identify new relationship, and new classification and new analysis. So based on this one, we can have a new data which we can analyze very easily. So it is continued. Next topic, we will discuss more.